So just like you, all functions have a parent, meaning that there is one function that's kind of in charge of everything else, and everything else resembles. They're not identical, but they're similar. And the parent function for a linear function is the equation y equals. Notice that in a certain sense, it's the simplest of all possible linear functions. If we were to consider this in slope-intercept form, remember that slope-intercept form is y equals mx plus b. So y equals x translates into y equals 1 times x plus 0. Now you know that m represents the slope. So in this case, the slope of the parent function for all linear functions is 1, which means as a fraction, this integer can be written as 1 over 1. We're looking at the rise compared to the run. Or another way of saying this is the amount of change in y when the amount of change in x is 1. B in this case represents the y-intercept, and that means the place, you can think of that as the place where the line will cross the y-axis. So we know this graph, or this line, crossed the y-axis at 0, or at the origin. So the graph of y equals x, we use the y-intercept and the slope. First I'll plot the y-intercept. Now, on my tick marks, enough to let someone know that I'm counting by 1, indicating what's going on. My y-intercept, I know that every time I go up 1 unit, or rise 1 unit, or the change in y is 1, the run is 1, or change in x is 1. So up 1, up 1, right 1, because change in x is 1. As I repeat this, up 1 and right 1, see some of the points in the line itself would be every single point that would make the function, which all linear functions are modeled after. Everything is some version of this that may be tilted this way, or maybe it's split up and tilted another way. All of them are this parent function